Let us look at proposition number 2 of book 6 of Euclid's Elements. The proposition says, if a straight line is drawn parallel to one of the sides of a triangle, then it cuts the sides of the triangle proportionally. And if the sides of the triangle are cut proportionally, then the line joining the points of section is parallel to the remaining side of the triangle. Okay, so what does that mean? We have a triangle. So the proportion is basically saying that if we draw a line parallel to BC, so let's take a point on one of the sides and let's draw a line through D parallel to BC. Again, we know how to do that. Okay, let me bring it into the frame and take the intersection, draw the line. So now this line is parallel to BC. Okay, let's mark the intersection of this line with the other side of the triangle. Now let's hide this line and this point. And let's join D and E. So this line is parallel to BC. So what the proposition is saying is that if this line is parallel to BC, then it will cut these sides proportionally. Okay, that is AD is to BD as AE is to EC. And it also says the converse. That is, if this line cuts the sides of the triangle proportionally, then it is parallel to the third side. Okay, now we have drawn it as a parallel to BC. So let's take care of that first. So what we are going to do is join DC and we will join BE. Here, if you notice that this triangle BDE is going to be congruent to triangle CDE. Why? Because they are between parallel lines and they have a common base. So they are equal to each other. Nowadays we say they are congruent. So these two are equal. Now let's compare BDE with ADE and CDE with ADE. Now ADE is a third triangle. These two are equal triangles. That means triangle BDE is to ADE as triangle CDE is to AD. The ratio between this triangle and this triangle will be equal to this triangle and this triangle because these two triangles are equal. If we look at triangle BDE and ADE, you will notice that if we draw a perpendicular on AB to E, then these two triangles BDE and ADE are going to be between or under the same height. Similarly, CDE and ADE will be under the same height. So which means we can say based on 6.1 that these two triangles are in the same ratio as the bases. So triangle BDE is to ADE as BD is to AD, and same is the case here also. Triangle CDE is to ADE as CE is to AE. So now, because these two triangles are equal, we can say BD is to AD is equal to CE is to AE, which is what we started off trying to prove. Now, the other situation is where we don't draw it as a parallel. Let's draw another triangle and let's take a point K anywhere on the side. Can be anywhere. Let's say on FG. And now what we do is we mark a point on FH so that it is in the same, the cut is in the same ratio as Fk and Kg. So how do we do that? Draw a circle, intersect and join these lines. So here what I have done is the radius of the circle is a multiple of Kf divided by Fg. As you might have noticed, again we join these two and we get the same diagram. The only thing is here we started off by saying D is parallel to BC. Here we start off by saying Fk is to Kg as Fl is to HL. We try to prove that these two lines are parallel. So let's see. We are given that Fk is to Kg as Fl is to LH. FKL triangle and KGL triangle are under the same height. Triangle GKL and FKL are going to be in the same ratio as FK is to KG. Similarly, triangle FKL and HKL are going to be in the same ratio as FL is to HL. Again, based on 6.1. And now, if you notice that this triangle GKL and HKL are being compared to, are in the same ratio with FKL. That means they are both equal to each other. If they are equal to each other, or as we say, congruent to each other, and they are on the same common base, that means these two lines are going to be parallel to. So we have proved both the cases. One where a line cuts a triangle such that it is parallel to the third side, then this line cuts the sides proportionately. And if they cut proportionally, then these two lines are parallel to each other. So that was the proposition number 2 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share it. That's it for now. Bye.